So in this last part, we are going to check how we can use LPy from other third-party programs, like a Python script, for instance. It is possible to access the different functions that you are using in LPy from the outside. So this is called the LPy API, or Application Programming Interface. And I'm going to describe some tools that we are using that are not directly distributed with LPy, but that are collected in a set of in a library that is called LPy tools. Okay. So briefly, what you would like to do from a Python script, typically, is to be able to load LSystem file, to set the axiom from the outside of the file, to run the LSystem and derive everything up to the final point of the derivations. You want to access potentially the LSystem global variable so that you can change them from the outside. You want to plot the LString, make use of the user, check the LString result, so inspect the LString, and then potentially manipulate the viewer so that you can manipulate the camera, set up the 3D view in the way you like. So we will briefly browse the different ways we can do this with the LPy facilities. I first remind you that when you have a LSystem, this will make it possible to go to apply the derivations through the different production rules. So you start by the axiom, and then you derive the axiom, get to the kth LString, and then up to the end. This is controlled, the end is controlled by the derivation length variable of the LSystem. And at each time, you can ask for the computation of a scene corresponding to your LString through the interpretation rules. Okay, you remember this frame. So a typical sequence from a Python script would be to import the library corresponding to the LPy API, and then to call a certain number of functions. And this is the typical set of functions that you would call. First, you load the LPy model from the file. So the file name would be here. And the function LSystem would make it possible to transform the file into an object in the machine that represents your LSystem. Then you want to compute all the sequence and then get the final result. This is LSys, so the object LSystem that you derive up to the end. Okay, and this gives you the final LString of your system. Then once you have this, you may want to compute the LScene corresponding to your LString. And then you would use this scene interpretation function of the LSystem object. And once you have this, you want to display the scene in the 3D plot. And for this, you you get the object viewer, which is in the object LSystem, in the model, in the LSystem model. And finally, you use this object viewer to display your LScene. Okay? Any question on this?
Can we, instead of displaying the scene, can we export the 3D model?
Yes, you can export the 3D model. There is a function, I don't remember the exact name here, but I can tell you after that, where you can export the .obj object.
Without creating the viewer and the...
Yes. Okay. So I just wanted, okay, in order for you to manipulate at least once, so that you are able to reproduce this on your own, I wanted to give you a small program. This is the Hello World program that I improved a bit. So where it is, so it's this von Core fractal, but I improved it so that I can parameterize the opening angle here. That is a bit more sharp than the one in the classical von Core curve. Okay, so here I just introduce this alpha coefficient, or the angle, in order to control the opening of this. Okay, so this is through this formula here. And then the L system production rule, which is the same as before, but here this is controlled with the alpha. Okay, so it's I mean, you can play with it after that if you want. The point is that now if I change this, I will produce this fractal, but with different potentially if I change the alpha with different angles for the opening of this shape. So I have two control parameters, one that controls the n here that controls the derivation length, and the second one, alpha, that controls the opening of the object. And my point is that I would like to explore all the shapes that I could have when I vary n on the first hand, and alpha on the other hand. Okay, and it's usual. I mean, usually you want to do this. You have a system. You want to vary two parameters and see the impact on the shape of your system. So for this, you may control these parameters from the outside. But then first, you need to do something. You cannot do it straight in this way. You need to edit this program first, a bit, not much. And what you need to do is this. You need to say that these parameters that you want control from the outside, they should be declared as external parameters, okay? And that's it. It's not much. So it's a way to say, in my program, not everything will be exported or will be visible from the outside, only the ones that are declared as being external parameters. So now, once I have these external parameters, so this happened in the LPy file. Okay. Now I can use these parameters from the outside in the Python file, for instance, and declare, for instance, a dictionary. And now I give my own value from the outside in the Python file. So, for instance, here n is 4 and alpha is 60. And if I want to apply this new value to my L system, I just, instead of, before I had this, I was creating this object from my LP file using this command. Now I add the dictionary value with the variable. Okay, and then you do exactly the same thing as before, you derive, etc. What you could, I don't remember whether I put it. What you could do is this also. Instead of giving a dictionary, you change the variables one after the other, just by saying that the alpha parameter, alpha variable of the S system object should take a certain value in your Python file. Is that clear? Okay, good. Now, if I want to plot my L string and plot it on the string, then there is a plot command that takes the L string and that will show the actual value using the interpretation laws.
What is plotting here?
Plotting is just displaying.
But I thought we were outside of the LPy Studio.
Yes, but you still can call the 3D viewer.
Okay.
So if you plot, so the plot does a lot of things. In particular, it calls for the interpretation rules, and it also create the 3D viewers and also display the. It does all things all together. Okay. Now, if we go through the different parts, you may do the different series of steps in different manners. So briefly, you need to import the functions of OpenLR LPy, which is, for instance, this one is L system, so it is imported here. You create your L system in this way with a name, or by giving the file, or by giving a string of character that will correspond to your code. Okay, so either you read a file or you give a string of character. To create the variable, this is what we said. You just create a dictionary, and then this variable var1 and var2, etc., should be declared as being extern, and then you create your system by passing this the corresponding dictionary. Okay, so this is a bit redundant, sorry, with what I was saying before. And now, if you want to make derivations, you can control the number of steps, because there is in the L system the predefined variable derivation length, and you may change it in your Python code. And you would call the derive, which would apply derivation, the number of steps that is defined here. Then you have a sequence of derivation, because here you don't compute all the intermediate steps. You get just in the L string here, you get only the final step of the derivation. If you want to have the intermediate stages, then what you need to do this or this. Maybe this is the simplest. You say for L string in L system, and you do something with the L string, print, for instance. Okay, so this is the most simple. If you want to go through all the derivation, you just say for L string, you have L system is a sort of iterator object, and you say for my L string in my L system, do something. Okay, but you can be a bit more specific, saying that you get a L string, an initial one. So, for instance, by using the L system axiom, okay, and then for the amount of derivation that you want, then you just compute the L system derivation applied on your L string a certain number of at a certain point up to a certain number of time, which is 1 here. So it's 1 step of derivation. Okay. Now, for the interpretation part, you have at some point you have your L string. So imagine that I just computed the sequence of L string derivation. I want to interpret the L string and get the interpreted string. So this will be by doing like this: L system interpret the L string, and then you can save all your result by using simply the write L string and open file, write the L string and close things. Okay, and you can plot the interpretation by using this plot command. I won't go into the details of this, but maybe you just need to know that you can also control the viewer itself by positioning the camera in the 3D world. And this, for this, you would get an access to the viewer, and then you have a certain number of commands that makes it possible to get the position of the camera, to set up the position, the direction, for instance, of where the camera is looking at. And then you finally can save a snapshot of your object in the position of the camera that you have set up.
Yes.
That is interesting. Because in our pipeline we use Blender to finally do the same thing as
Yeah.
what is shown here.
Yeah.
So maybe we can just get rid of Blender and all the complex things, because
Yes.
Blender comes with
With a lot of things. If you want to do some simple things, you can just use this save snapshot.
What do you think, David?
I think it offers quite a lot of possibility, Blender, in terms of texturing, lighting.
But we don't
Yeah.
use textures in our.
No, but if you want to see future development,
It's not the same use actually. If you want to have a sort of exploration of your shapes and how they depend on your parameters, etc., you don't need to go to Blender.
Yeah.
But if you want to make a final picture for a paper or to show that your object is realistic, then you need to have these shaders, and then with complex rendering of the scene. And then in this case, you might want to go to Blender and render your system with
But
Blender.
actually, we don't use the advanced features of Blender.
no, but for example, Frederic is now starting his PhD, where he moves the camera with reinforcement learning algorithm, etc. And so it's easier to interact with Blender for this than with LPI maybe. So if you want to
It depends on what you want to do.
It depends on because with the lookat function, you can control the camera. And
You can control the camera. Actually, there is in the viewer. I don't describe this here, but you can get the projection of the scene in the plane, in the focal plane of the camera, which means that you could compute whatever type of pixel algorithm that you want to do on your scene, just from the projection.
And we can, for example, hide some organs easily in the plant, for example.
Yes,
And,
yeah.
and show just the fruits, for example,
Yeah,
or the
yeah.
stem.
Well, actually, if you want to do this, you just need to control which interpretation rule you are applying.
But like if you want to add some HDRI background, for example, or things like that, you can do it easily in Blender.
But again, it depends on what you want to do.
Yeah, yeah.
So it may be overkill to use Blender for very simple tasks. On the other hand, if you want to have a nice rendering and maybe fine-tune control on the way you compose your scene and whatever, then you need to use Blender.
Yes, but we can just, if we want to use Blender for advanced feature, we can just extract the scene as OBJ file and
Yeah.
import it in Blender
Yeah,
and make
yeah,
it
yeah,
all.
yeah.
Because what we are struggling with is lot of, Blender comes with a special version of Python, so we have to copy all the libraries from the standard, the Python installed on the host to the Blender's directory.
Yeah.
Okay, just I think.
We could discuss this afterwards if you like, to see the pros and cons of using this Blender or getting straight from LPy. So in LPy, we started to develop this library that is called LPy Tools. For the moment, there are two main components of this library. The point sampler that was described by Ayan yesterday. So this will continue to evolve to our most realistic simulation of the 3D point cloud to mimic, like for instance, a camera that would take the picture, or to mimic a laser scanner, or to mimic different types of sensors. Okay, so this will evolve in the future. We created also a snapshot component that makes it possible to vary one or two parameters in your model, and then to create all the snapshots that corresponds to the combination of these two parameters, and then create a figure. This is very convenient when you want to analyze how the sensitivity of your model to certain types of parameters. So I will you can check this. I gave two files for you to check this, and you will see that it's very convenient. And what is coming? There are a number of things that are coming, but the next two ones are tools to manipulate light in the models, like for instance to describe the course of the sun during the year and during the day, to position your, and depending on the latitude and the longitude of where you are on the Earth. So this is very convenient to position precisely the sun at a certain moment of the day with respect to your plant, if you want to have this type of application. And also we are developing a library in order to export and import other formats into the LString type of files. So we already have MTGs. 3X is the library, is the tree library developed in our group, but there will be others potentially, and then they will enrich this component of the library to have a better exchange with the outside world. And for instance, one important thing for this is to be able to create axioms directly from sensors, from images, or from people that have already constructed their plants outside the LPI world. Okay, so just to remind you, so I have 2 slides on this. The point sampler is simply the call of this function. So you import the function from the LPI2's point sampler module, and this is the scanutils facility, and you import this function. And this function comes you need to pass to the point sampler a LString, a LSEN, a label map, so the one that Ayan was explaining yesterday, just to give the correspondence between your LString entity and some number that you will use, and the number of points. And these are the names of the files that you want to, in which you want to write as an output. And this makes it possible to pass from LPI model to a point of clouds of this LPI model. Okay?
Sorry. In the self-avoidance example, you need this cloud of points, but you build it as you build the string. So isn't this easier?
In the self-avoidance, yes, we didn't do this type of example, but we could have subparts of this, because this is already high-level component where you have points everywhere on your plant. Maybe for the self-avoidance, you just need to build points corresponding to your entities at some precise places, not everywhere. Mm-hmm. Okay. So you could use sub-elements, sub-components of this point sampler in order to make this, but we didn't do it for the moment. So what we use for the self-avoidance stuff is the vertices of the different components. So we don't add component to the elements. We just use the natural vertices of the cylinders, for instance. So, yeah, which in many cases is enough, but may happen to be a limited factor at some point. Okay. And the snapshot library, it comes like this. You from LPI2 snapshot, you import this function, and then this function you need to give it and it's not an array in 2 dimensions, but it's a set of couples of points corresponding to the variation of your variable, the couple of points for which you want to see your simulation. And for each of these couple, you will apply the model, define the LPI model, define the model in this file name. And then what you give is a list of 3 variables that you want to vary. So for instance, the n and the alpha before. And then a list of fixed variables, because you may want to register the fact that a certain number of values were used and had these values, but didn't vary. Okay, and then there are camera settings that you may play with also during the, and with this, with the, you can create figures where you have the two variables that you are varying here for n equal 2, angle equals 70, and then for n equal 2, angle is equals 70, we have this type of figure. Here we have n equals 4, angle equals 85, and you see that we have a different type of figures. So you could try to have this with your plants instead of this hello world example. You could replace this. So I propose that to finish this small presentation, that you try to create a figure like this with by replacing this LPy model that would be given here in the model file name. I gave the hello world example. Now you can replace this with your own example. Change the variable that you want to vary in your model. Like for instance, in your carrots, you could change the number of leaves, for instance. And then launch the system, and you will see that it will create this type of figure automatically for you. And the good point is that it takes, you can control the camera, so you can keep, for instance, always the same camera on the in your figure, which is sometimes difficult to get if you do it by hand, or change the camera like by rotating it around the plant, this type of things. Okay? I think we are done now. Yes. So if you like, we can. So I created a directory that is called 5.2, I think, in the Dropbox, and then you can go there, and you will have a Python file and a LPy file. So you can look at the Python file and change the Python. Take your copy, for instance, at this place, your preferred LPy file. Declare the external parameters that you want to change in your file, and then use the same Python file that I gave you. Change a bit the file name, etc., to create your own figure in an automatic manner.